Hello everyone, welcome to Neso Academy. In the previous lecture, we understood the difference between VHDL, Verilog and C programming. But before we start practical implementation, we need to understand an important topic, EDA Tools. The answer to the question that where we will implement our VHDL code. Now, EDA tools play a very important role in converting our design into actual hardware. So, today's lecture is all about EDA tools and its type. Therefore, the name of the lecture is EDA Tools for VHDL. Here we will see its definition and types of EDA tools. So, let's start without any further delay. So, in this lecture, we will cover the following topics. The very first, EDA tools. Here we will see what EDA tools are. Then our second topic, types of EDA tools based on digital design process. Now let's start with the first topic, EDA tools. Now we all know that EDA stands for Electronic Design Automation Tools. So, EDA tools are specialized software services that helps engineers to design, simulate, and verify electronic systems. In simple words, EDA tools help engineers design and build digital systems efficiently. Now, an important point to understand that EDA is very broad concept. It includes tools for analog design, digital design, PCB design, VLSI design, and many more. But in this lecture, we will focus on EDA tools used for digital design process using VHDL. Now, digital design process. As we already studied, that digital design process consists of several steps. Let's see them one by one. The very first step is digital circuit design or schematic synthesis. The idea or the goal over here is to create a design using VHDL code. Then, second step is simulation and third step is verification. Here, we check the correctness of VHDL code. Then last step is hardware implementation. As the name suggests, over here, the VHDL code is converted into actual hardware. Now, for each of these steps, we have different types of EDA tools. Let's see them one by one. Now, we are done with the definition of EDA tools, which means we are done with our first topic, EDA tools. And I hope you understand what EDA tools are. Tools that helps engineers to design and verify electronic systems. So let's start our second topic, types of EDA tools. Now, EDA tools are classified based on digital design process. There are different types of tools such as design entry tools. Here we create the design using VHDL coding or Verilog coding or even with schematic diagrams. Now, based on digital design, we have multiple softwares such as Xilinx Vivado, Intel Cortex Prime, and Model Sim. Now, Vivado is highly used tool for modern high-power Xilinx FPGAs, while Intel Cortex Prime is a standard tool for Intel-based FPGAs. And Model Sim is very popular third-party simulation tool that helps in debugging. So, for design entry, we can use Xilinx Vivado and Intel Cortex Prime. Now, this is the point where digital design process starts. Now, let's see second type of tools, simulation tools. Simulation tools are used to test digital circuits before hardware implementation. Here, we apply inputs, observe outputs, and check the correctness. And for simulation, we can use Xilinx Vivado and Model Sim. Now, Model Sim is very good simulation tool, while Intel Cortex Prime can also be used as a simulation tool, but some users find it less intuitive compared to new alternatives. So, in this process, simulation helps to detect early errors. Now, third type of tools, synthesis tools. Now, synthesis tools convert the VHDL code into hardware logic, which means HDL code into logic gates, or we can say a netlist is generated. Now, we all know what is netlist. Connection of logic gates or hardware logic, which means a circuit diagram. Now, for synthesis, we can use Xilinx Vivado and Intel Cortex Prime. Now, in this process, the design starts becoming hardware. So far, we have seen design entry tools where we write VHDL code, simulation tools where we verify VHDL code, and synthesis tools where a netlist is generated. Now, let's see few other types of tools. Implementation tools. As the name suggests, implementation tools are used for physical realization of the design. It includes placement and routing. Now, we all know what is placement and routing. Let me explain it again. Placement means arranging logic cells or logic circuits with area and power utilization. And routing of connections means creating electrical connections between those logic cells. So, the design is mapped onto FPGA and ASIC hardware. Now, for implementation, we can use Xilinx Vivado and Intel Cortex Prime. So, in implementation tools, the VHDL code is converted into actual hardware. Now, let's see last type of tools. Verification tools. Now, verification tools ensures that our design is functionally correct and timingly correct. Now, what is functionally correct and timingly correct? Functionally correct means that our design is working as it was specified or it was supposed to do. And timingly correct means that all timing specification, that all timing constraints and propagation delays are properly verified. And for verification, we can use all these three. So I hope you understand the different types of EDA tools. Now, apart from these three tools, we have multiple more software. Now, different tools are designed with different focus. Some are better for simulation, some for synthesis, and some for implementation. Now, based on the requirements, engineers may use different tools. But for this course, we need a tool that supports VHDL coding, allows simulation, synthesis, and implementation. And it should be easy to use. So, for this course, we will use Xilinx Vivado because it supports the complete digital design process. And it is widely used in educational institutions and industries. And it provides free version. So, this makes it ideal for learning and practical work. Now, once again, digital design includes design entry, simulation, synthesis, implementation, verification, and tools like Vivado can handle all these steps. So, I hope you understand different types of EDA tools, which means we are done with this topic, types of EDA tools, which means we are done with this lecture. I will see you in the next lecture where we will install Xilinx Vivado and start working with it. So, see you in the next lecture. Thank you.